Hi, I'm Jill Vogel, and I'm here to talk about how you can develop content on the OpenEdX platform that you can port to other LMSs. What I'm not talking about, and what I probably should be, is how to create content that you can use across different courses and share with other course presenters. But Jane Park gave a great presentation about that yesterday, about how to use Creative Commons and how to encourage a culture of sharing with your content. But I hope you got to see that. So I'm with OpenCraft. But before I came to OpenCraft, I worked for the University of Adelaide on their MOOC project. And one of the challenges that we had with that, which is probably something that you all share, is we were a very small project. We were only doing a couple of courses, but we had compared to the on-campus course creation, we had a considerable amount of resources. And so all of the custom content that we created, we needed to be able to use it on our on-campus courses. Our on-campus students were using Blackboard, and we were going to be moving to Canvas, but basically we just couldn't justify using very edX-specific technology to develop our course content because everybody wasn't going to be on edX. And so we ended up looking into basically all of the opportunities on the platform to develop content that we could use elsewhere. So I'm going to talk about a few of those. I'm going to start with really obvious and move to a little bit more complicated. So the first one you probably heard of, YouTube, yeah. So you already know that when you publish your videos on YouTube, you can use them on any website anywhere. The video upload process that OpenEdX added recently actually makes that even better. They host, if you upload your videos via that process, they generate downloadable video links in various formats and various sizes that can be used in mobile and low bandwidth environments. And those links can be used from anywhere. It's a content delivery system. It's non-authenticated. You could use them in whatever courses that you want. I don't know how, if that's ever going to change, but right now those links, they're usable from everywhere, so you might as well take advantage of the content that's already been published. And also your downloadable transcript links too. They're under the same policy. Another core functionality in OpenEdX is iframes. So what's an iframe? It's basically just a window into a website. And nowadays we can do really amazing things with just basic client-side hosting. So you can develop an HTML page with JavaScript and CSS that does really amazing things. And though if you don't have a database backend and you don't have an app on the back of it, you can't do a lot with storage. You can do a little bit of storage with cookies and stored data. And so one of the interactives Adelaide X, we started calling these interactives. But basically it's just a website. It's a little website that illustrates a learning concept. And so one of ours was a wine appreciation course. And so we had a series of pages that asked people about various characteristics of wine, like color and clarity and aroma and flavor and all of those. And we gathered up all of their answers into this lovely little snooty sentence that basically described your wine. And that used cookies to just store the data across pages. So the more complicated version of shared content is LTI. So OpenEdX supports LTI in two ways. One of them is actually pretty unusual. You can use edX as an LTI application. So LTI is Learning Tools Interoperability. So you can take a piece of your edX course and embed it into another LMS. This is a new feature. It's still kind of under beta. Oh, I don't know what they're calling it now, but it does work, and it is a really useful way to take an edX course module and actually reuse it. And the other way is more traditional. You can build an application that uses LTI to talk to edX. And basically, the LTI protocol, what it does is it does two things. It does authentication and grading. That's it. So the LMS vouches for the user. The application says, oh, you must be a user because I've got this message that I trust. Creates a user account on the application, then the user can then use it. And if it's set up to, it can send back grades as well. So the course that we used this with in Adelaide X was Think, Create, Code. We basically built an LTI application that allowed students to create a portfolio of artworks and while they were learning the Processing.js language, and they could share those artworks. The other nice thing about building an LTI application is you get to decide what the access is going to be. So we said, we're going to let all the students of our edX course use it, but we're also going to make it available to the public. So when students share their artwork, they get a link that they can send to anybody. And so they could share it with their family and friends and put it on social media and say, look at this thing that I did. And it lets you actually go to the application, view the code, you can modify it in place and make changes and see what it does and actually interact with it. So that was pretty popular. It was very cool. And OpenCraft also developed an LTI that's it's a peer instruction tool. It's following the Eric Meser procedure for teaching, letting students teach each other. And I think that's it. I don't know how I'm doing on time. Did I rip through it?
Yeah, no, you're doing great. So
Sweet.
You want to open up for Q&A now?
Yep. Oh yeah, and if anyone wants to learn more about LTI, we're giving a workshop tomorrow where we'll build a small LTI application. And yeah, I'd like to thank OpenCraft and University of Adelaide for letting me use their images. Does anybody have any questions? Yeah, good. Thanks.
Hello, my name is Yasser Bashir. I'm the CEO, co-founder of Arbisoft, which is an Open edX development partner. We have a team of almost 50 people that has been helping with the Open edX development for close to 3 years now. I don't know if many people know that. And I'm here to talk about Play Physics, which is an Arbisoft project to integrate interactive 3D content into Open edX. So a bit of background about what Play Physics is. One of the problems in the developing world, developing economies like Pakistan, is that very few high school students, a very small minority of high school students, actually get to ever do practicals in their course. So just to use this as an example, in Pakistan, out of the 5 million high school students that go to 12,000 high schools, less than 20% have ever done a practical from their curriculum in an actual lab. And that's a conservative number. So that's where the idea of Play Physics came up with. It's a gamified, interactive, virtual lab environment which allows students to perform experiments. We initially started with iPad and Android tablet applications. This was a very successful project. We took 12 experiments from grade 9 and 10 high school physics books, and we created them virtually. This was a top winner in a nationwide competition for educational content, and we also won a decent grant for it. We then piloted this in 5 schools with more than 1,000 students. 80% of those students were females, which is really amazing. And this was also a great success. Kids just loved interacting with tablets. Turns out most of the kids actually did better on these experiments than their teachers, which was really amazing because they naturally get technology better. So then the question arose of how do you take this and scale it up to millions of students? Obviously, because we work with Open edX, and that's our answer to it. There are multiple ways of integrating something like this with Open edX, LTI. The one we chose is an XBlock wrapper around the Unity 3D web plugin, which is what we used for our apps. Unity 3D web plugin allows Unity 3D content to be hosted inside web pages, and the XBlock allows bidirectional communication between the plugin and the host course. So the plugin can post scores to the course, and the course can send instructions to the plugin. On to a quick demo. If you see here, this is the course. On the left, all of the experiments are listed. The students can click on an experiment and then read through all of the instructions. And then they can click on the assessment to actually launch the Unity plugin for the assessment. So all of the instructions have been transferred from the course to the experiment, and they're always available to the student. So the students can, at any point, go back to the instructions while they're performing the experiment. I fast-forwarded this. Normally, this takes a little bit longer. So they're supposed to do the exact same steps that they're supposed to do in an actual lab. This is specific heat of solids, weigh the block of metal, weigh the water. While they're performing the experiment, they're supposed to take down the values with pen and paper, boil the water until it reaches boiling point, immerse the block in it, take the block out, put it back, see the difference in temperature. Students are graded on how they performed all of the steps in order or not, and how fast they did it. And we randomize this a little bit, so the answer is slightly different every time. You can't use the answer from your previous attempt, which is how you would expect this in a lab to be as well. And then whether you answered correctly or wrongly, or however you did, the score is posted back to the host course so the students can track their progress. So some of the future work that we are planning with this, Unity deprecated their web plugin. So now we are going to build this integration with WebGL, which is the new standard, which is great because it's an HTML5 standard. We are planning to roll it out as a free course, so the 5 million students in Pakistan or in the rest of the world can actually do free physics experiments. We definitely plan to employ edX Insight so we can improve learning outcomes. And finally, Arbisoft does a bunch of work with immersive environments like the Oculus. It would be really cool to see this as a course where students actually wear an Oculus and do the experiment in an immersive environment. So this is some of the future work that's coming up. How am I doing on time?
You're doing good.
Thank you. That's it. Any questions?
I was wondering if there's any accessibility component, or is this sort of thing only really available to someone who can see and manipulate in standard accessible ways?
So we haven't done any accessibility work on the Practicals app itself, but that's definitely one of the things that we should look into.
I just had a general question about the students' access to hardware and if there are any challenges around that and what's the approach to that?
So obviously the best thing is to have a physical lab, right? But it's much more expensive. A tablet is something that's, I think, most schools can access. So I think access to tablets could be increased to 70, 80, 90%. Access to labs, as I said, is still less than 20%. So I think it's much more affordable. Does that answer your question?
Is this available even outside of the edX environment?
So the apps are available. We haven't pushed them on the App Store, but you can get in touch with me if you're interested in using the apps. And we're hoping that we can just push them to all of the platforms that Unity supports. So immersive environments, Oculus, zSpace, tablets. Unity is a great platform that way. It just produces it for multiple environments. Yeah.
How do you compare yourself to Labster?
I think it's very similar. Labster is very similar. I think we put a lot of thought into making sure that the experience of actually conducting an experiment, a practical, is as close to doing it in a lab as possible. So we actually try to mimic the lab experience. Labster probably doesn't necessarily, replicate they just have virtual experiments.
Can you talk a little bit about what you're going to need to do in order to make it work with WebGL?
So basically, it's not going to be a lot of difficult work. It's JavaScript glue code that has to be written. Some JavaScript glue code was written to create interoperability, back and forth communication between the X block when it was a web plugin. And that code will need to be changed to just make it compatible with WebGL. Otherwise, I think it should be pretty standard. Unity just exports to WebGL now, which is great.
It's nice to get to know that girls are playing physics with your simulation, and it's makes them very enthusiastic and involves them.
It's very encouraging. It's just.
Well, the big question is how far is it from real physics? How good is the simulation? Looking at your pictures, I'm not really sure. It's physics.
Yeah, I think it's not a replacement. It's the next best thing, like I said. And we try to make sure that the experiments are look and feel and the calculations are as real as possible. We add a little bit of jitter, just like you'd get in a lab environment, so that your calculations. But you would expect to perform a specific heat of solids experiment in a lab environment, perform the steps similarly, and let's say you've played with this, your odds of doing it well in a lab environment are way, way higher than somebody who's never touched the equipment. So there's definitely, this is not a replacement, but it's definitely the next best thing.
Are there any information about performance of students that after playing with labs are trying to work in real labs, comparing with the student that didn't have experience at all?
We haven't measured that yet, but that's something that should be measured. Our guess is that it should be
That
much
doesn't
higher.
help.
Yeah. Yeah.
Related to that question, have you looked at people who have done the experiments and been assessed on like an exam physics exam versus, doing the online 3D versus not doing it, and whether or not there's a learning outcome difference?
I think those are all of the things that we would like to do in future, not yet. Okay.
Any other questions? That's it? Oh, thank you.
Thank you.
Hi, so I'm trying to talk about adaptive hints today within 5 minutes. So we basically want to show you, so now OpenEdX, you can have hints implemented in the OpenEdX problem. So when students are doing the problem, you will see hints pop up automatically for that student. We want to show you how we write hints, how we generate hints, and then what hints do we think is useful to students. So a little bit about myself. My name is Jen. I'm a grad student at UC San Diego. I'm also the team lead of the Adaptive Hints Research Group, work under Professor Yaw Friend. So let's start with the outline. So first, we want to show you what different types of students, how they actually approach a problem. And we want to show you how we do hint generation. And then at the end, what hints do we send? We call them pattern-based adaptive hints. So let's start with student behavior analysis. So for a lot of problems, there's one correct answers. And we think there's multiple almost correct answers. So one type of student, a student who don't need help. They would just go directly to the correct answer. We also have one type of student who waste time wondering. So this type of student actually approach one of the almost correct answer first, and then they spend a lot of time trying random stuff, and eventually they'll get the correct answer. And the last type of student who wondering, but eventually gives up. This type of student actually try more than one almost correct answer, but actually never got to the real correct answer at the end. So our hint want to be sent at these 3 specific locations where student actually got to an almost correct answer, and we want our hints to help them to go directly to the correct answer from there. So how we actually generate hints. So we do it in a quarter. At the very beginning of the quarter, we will have TA and tutor for a class. They will try to sit in front of a problem. They look at the problem. They think of possible mistake a student could make. They will find patterns in there, and they'll write hints corresponding to those. All this will be before we release the problem set, just so that when we actually have students come in, they'll actually see some hints coming in. So student comes in, they start to do the problem, and our system will only capture the student when they spend more than a certain number of minutes. So the reason we do that is we think under that certain number of minutes, probably those are the students who don't really need help. They will just go directly to the correct answer. So after the system captured those students, it starts to parse the student's answer, and then they will match the pattern with whatever the TA and tutors were at the beginning. And then they will send the corresponding hints. Now, what if some of the mistake that student made is never actually captured by TA and tutors ahead of time? Like TA and tutor actually never thought of such mistakes. The system will aggregate all those mistakes and identify something we call confusion hotspot, where we will group similar mistakes from student attempts, and then we'll send them to TA and tutors again. So TA and tutors come in, they look at the hotspot, and then they will find new patterns in there, and they'll write more adaptive hints. So this whole process is happening as the course go on, as students are doing through the course. So you will see more and more hints added in the system, and people will get more and more help at the end. So what do we actually send? So I want to say there's 2 key points for the hints that we send. First of all, we want the hint to indicate the correct part of the answer, is which part of student solution is correct. And also we wanted to get hints on incorrect part of the answer. So the first part is done automatically by the system. And the second part is what TA and tutor actually go in and write. So here's an example. So here's the problem. So we do this in a probability and statistics class in UC San Diego. So here's the problem, blah, blah, blah. There's the solution. That's the correct solution. And this is one of the student's attempts. So in this attempt, student actually got the first part correct, just written in a different form. This is the first hint generated automatically by the system, where the system will say the first sub-expression is correct, and it will also tell the student how to write it better, and then tell it what it means. So these are automatically generated, indicating the correct part of the solution. And then this is what the TA or tutor write. You need to subtract the numbers of hands, blah, 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 which is the second part, which is what they need to think about at that point instead of go wandering around. So basically this, we tell them you got part of it correct, you need to think about more on this part. So that's what I want to share with you today. Thank you. Yes?
So you said you're collecting data as the course is going on. What are you using for your data source and how are you processing it?
So yeah, so basically we're collecting the students' data from like a real class we're doing. So students will go online, go to OpenX and do the problems, but we actually have a physical class going on in the quarter. But unfortunately, it's public school, so we are unable to use that data at this time to apply to our research. We need to apply, there's a standard procedure. But yeah, we'll eventually use that data to show how this can help students and what's the rate that students actually increase using this versus not. Yes? Yes?
So does the TA give the hint at around the same time that the student gets this system-generated hint?
So right after the TA actually put in the hint in the system, it will actually start sending. So the TA and tutors, so the TA will first come in and then write some hints, student come in and start doing the problem. And then along the way, TA will write more hints on the path. Mm-hmm.
Are those adaptive hints manually generated by tutors, or do you use an algorithm to automatically find patterns and retrieve?
Yes, we do both. So for the system-generated hints, we actually have the system parse the student answer into a tree, and then we do pattern comparison, where the system actually automatically indicate which part is correct. That system can do. But for the part that what students need to do next is where they actually confused about, that's where TA and tutors write hints. So we do both.
Okay.
Mm-hmm.
Any other questions?
All right, thank you.
So basically, I'm co-founder of Wrecking Gang. We are OpenEdX provider. We are from Ukraine. And recently, we have been working with guys from OpenEdu.ru. It's like Russian X, so call it. So it started in September 2015. It's about 10 universities making 100 courses on that platform. And I think it's about 150,000 users you have.
120 right now.
And 20, like approximately. So we did a lot of customization of the platform, but the most interesting for me and for our team was the proctoring part, because at that time proctoring was announced in OpenEdX, and as you know, now in a standard OpenEdX you have only software secure proctoring, and we faced that some universities has already developed their own proctoring systems, and there are some startups who can make proctoring way more cheaper than CyberSource, software secure. So what we need to do? We need to integrate Examus proctoring into OpenEdX. We need to integrate ITMO university proctoring system for their students. And we've created on-campus proctoring system. What for? Proctoring, cyber proctoring are really attached things. And not every instructors and teachers in universities understand how to use it. Some some teachers just like to get the classes like old-fashioned, make exams. So we just make an integration between the classes offline and online learning. I will tell you a bit later about it. And because we had 1, 2, 3 proctoring servers in one platform, we should create a feature that can like split. So you can make proctoring service per course. So it can be one course with one service and other courses with another. Like 2 words about Examus. As well as the software secure, it has the cyber proctor and human, who is looking for the students. They have a lot of things like face recognition, eye recognition. They can hear somebody talking with you. So like it is like almost impossible to cheat on this exam. And there are a lot of blah, 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 blah. But the main thing is they can do it for $3 when Software Secure can do it for 15. And it is great, I think. MIT guys and fun guys are already interested in like integration with Examus, as far as we talked earlier. The other thing is on-campus proctoring system. So several words. You have a class with the computers. So students came to that class. They open the OpenEdX and start exam. But before that, teacher or like assistant just tracks their IDs and it allows them to pass this exam. I can show you like very brief how it looks like. So we have the student who is ready to take an exam. We have proctoring. So student has already logged in and I can approve. And student should start an exam, but something works, and activate. So here we are, starting an exam, and I can add comment, I can skip it, I can cancel, I can add the session of the students, and all the history is available into Archive for the teacher and all that stuff. Move next. So it's really, really easy and it's free. So why not? And multi-proctoring, like it works really, really simple. You have additional extension like proctoring services in instructor tab. So instructor before the exam can choose what proctoring system he likes to use. I think it's all. So like lightning talk, 2 minutes. Maybe you have questions. Yeah.
For the first assistant you're talking about, is that one proctor, one student? How do you?
No, it is one proctor for up to 12 students actually. So I had this. Can you see this image? So proctor can track all the students who are working now. He can. I have this actual big picture, but he can chat with them. He receives the notifications from the cyber proctoring about like cat was walking around and okay, it is like bad thing, you know, 3 bad things and you will go out, something like that. So yeah, by $3 an hour, you won't be able to look into one person, like 9, 12, things like that.
So do you think that it's effective enough that one proctor monitor?
Yeah, it's effective enough because like almost 90% of like things of cheating are caught by the programs, and the human is actually needed because of it's psychology, you know. If you're working with the program, you think, I am like better than program. And if you know that somebody is looking from that side of the screen, you want it. They made some research. I don't remind like the numbers, but it's effective. Okay.
Any other questions? One in the back.
Yeah.
How do you verify the students to make sure that's exactly the students who should take the exam?
By IDs. So they, in every program, or it can be exams, it can be software secure, it can be this on-campus proctoring. They show their IDs, they show their faces, and Proctor knows what students, like name and surname, should pass the exam. So like,
so you need a quality picture for the
yeah, it's quality picture, and this video is stored, and we can watch it once again if needed.
Okay.
Mm-hmm.
What if they have a nice makeup?
And then it's good for them. Yeah.
Practical question, how do you handle toilet breaks and those kind of things?
In exams,
Yes.
yeah, they should go before. That's
So they can't have a break?
no, they can't.
Okay. And in the human one at the moment in our university, they get escorted by a human.
I'll add some information. The thing is, each of 8 universities can set their own rules. Examus is a provider of proctoring. So if one university says, okay, you can have your toilet rules, then they are using those rules and helping the university to proceed the proctoring session. But the university is main responsible person for the results.
Okay.
And the Examus is just helping the university to achieve these results. So
Yeah,
they
thanks.
Side of proctor, no breaks.
Uh,
So
I,
have your ice cream
once again, they have some level of doing bad things, so they can or make it okay or not. Mm-hmm. Okay. Yeah.
Assuming, say, for example, if a student cheating, right, can the proctor take the control of the computer and block it, or?
No. We, like Examus, don't control the computer. It captures the screen. It can see that no other windows or browsers are opened. It can capture like the sounds and all the stuff, but we don't have an access. It's like it's prohibited. The only way they have like to violate the student, they can just end the session and write the comment. So like student behavior was very bad, and he need to make one more try on the exam, but this try was failed. Yeah.
This will be the last question, sorry.
Validate the student is actually the student. Are you doing anything like face recognition?
Yeah, face recognition, eye capturing, so they understand where the student actually is looking. Before the exam, students should take his notebook or tablet and show the room, so he won't have some blackboard outside or TV screen where somebody will help him. So like it's almost 99% sure that the students won't cheat, or if he cheats, he will be like, we will know about that. Okay.
If it's quick, sure.
Yeah.
How does the proctor know what the student should look like? Is there the
No,
account picture?
what-
I know you asked that, but like, what if I change my account picture? I'm the student. I change my account picture in the profile.
No. In profile, you may have the picture, but it's like not needed. We know the name and surname and details of the student because universities knows his ID. so the student shows his ID and shows his face, and a proctor sees like we are taking like high-res photo of that, and yeah, it's on video is also available.
So
Okay,
thank you very much.
thank
Peter.
you.
I was going to say,